Hello, and thank you for joining us today. We are very excited to present our CST 498 project, the RC Pi Car. It is a revolutionary system designed to automate vaccine transport in hospitals. This team, Group 2, consists of myself, Kentrell Ziegler, and Mr. Cody Jordan, as well as Austin Merritt. We have all came together to create this innovative solution. So let's dive into how this project is addressing a critical need in healthcare logistics.
Hello, my name is Cody Jordan, and I will be going over the next few slides, starting with the problem statement here. The three topics for this is timely and secure vaccine delivery is critical, risk with manual handling, such as delays, exposure, and errors. That's with human intervention, so lack of automation. And then a need for reliable automated transport solutions so that we can bring in that automation that helps cut out that manual labor part of it, which could increase risks because human error is effectively more common than computer error. So, in hospital settings, timely and secure transportation of vaccines is essential for patient safety and maintaining vaccine efficiency. So, however, manual handling can lead to delays, exposure to improper conditions, and handling errors. This creates a significant challenge, especially when dealing with sensitive medical supplies. So our project seeks to address these by providing a reliable, automated solution that minimizes human error and ensures efficient vaccine delivery. So our end goal here is to just automate everything so that you can kind of tell the RC car where you want it to go. So the delivery method would be the RC car, say room 125, or deliver these medical supplies to here, and it'll take over the rest from there. The sensors, everything on it, should be able to handle um, any type of delays in terms of path being blocked so it can veer around it, anything like that. And it'll be more timely, more efficient because you're not having to, set it up every single time. You can have it prepare itself for each delivery that it needs to go to.
Good evening. My name is Austin Merritt, and I'll be discussing the project overview and introducing the Pi Car. Our solution, the RC Pi Car, is an autonomous and remotely controlled vehicle that transports vaccines within hospital environments. Using Raspberry Pi technology sensors and real-time monitoring, this system ensures temperature stability and timely delivery. The car can switch between autonomous navigation and manual control, providing both flexibility and safety. This innovative approach has the potential to revolutionize vaccine transportation.
Next slide here, we have building the RC Pi car. So we have hardware, the FreeNova Pi car kit, Raspberry Pi 4, sensors, motors, batteries. Next, we have software, so the Raspbian OS, VNC, virtual network computing, Python for algorithms, and then integration, combining hardware and software for seamless operation. So I touch on VNC a little bit more. That's kind of like remoting into the Pi card. So it's just a remote function that allows you to ping the card to make sure you have a connection, and then to send information to it via IP to tell it kind of what to do or where you want it to go. To build our RC Pi car, we followed a detailed design process. For hardware, we used the FreeNova Pi car kit, Raspberry Pi 4, and various sensors and motors. On the software side, we use Raspbian OS and the Python to implement navigation algorithms and real-time monitoring. And then by integrating software and hardware, we created a vehicle capable that is reliable for operational use in a hospital environment. Um, One thing about this is the FreeNova PyCar kit did not come with the batteries. We had to get special batteries for it, which would power the entire uh, RC car. And then the Raspberry Pi 4, we went with the 4 over the 5 because the 4 had better input-output features. It also is a little more reliable, functions better with the sensors overall based on a lot of the research we were doing. So that's why we chose the 4 over the 5 and didn't get like the newest thing. It's just more reliable. And then our end goal here, we still have to polish the RC car a bit. add a little more functionality to it in the way we want so that it works as if it was in a hospital environment. Currently, it does do quite a bit of the features that we wanted, but hopefully in Capstone 2, we want to tailor everything to work the way we want, and we have that end goal result of our RC Pi car working the way we want, such as sending in a signal, go to this room, it'll head there, drop off the product it needs to, head back to its original destination, whether to charge or to just sit for the next instruction.
So what are some of the key features that makes the RC Pi car unique? The RC Pi car boasts several key features. It uses advanced navigation systems to autonomously avoid obstacles, temperature sensors, which can monitor vaccine conditions, ensuring safety during transportation. Additionally, users can track the car in real time and control it via IP through the mobile app. These features make the RC car a unique and practical solution for vaccine transportations.
So, our challenges and solutions. Like any complex project, we face challenges. Wi Fi connectivity was initially a concern, as the seamless operation of a hospital depends on a strong signal. And not alone just with the hospital, our project needs to work flawlessly on a signal. Now, we do have other solutions such as a manual drive, but we kind of want this to be as autonomous as possible. We have optimized the system to handle brief interruptions without losing all of its functionality. Battery life was another issue, which we addressed by making power saving features and planning recharging strategies. Debugging navigation was also a challenge, but through iterative testing, we are trying to ensure reliable obstacle avoidance. Now, that's going to take a little bit of time because things move within the hospital, but we uh, given enough time, can probably make something that would avoid any obstacle, whether it's people or maybe a chair that was placed on the left yesterday is placed to the right, and to make sure that this RC Pi car is without incident. Let's look at some practical applications of the RC Pi car. In one scenario, a pharmacist will dispatch the car to send vaccines to a pediatric ward. The car autonomously navigates hospital corridors, avoiding obstacles and updating the pharmacist in real time via the app. In another scenario, during a network outage, a staff member manually controls the car to complete an urgent delivery. These use cases demonstrate the car's versatility and reliability in different situations.
Our efforts culminated in a working prototype that integrates hardware, software, and networking. The RC car has been tested in simulated hospital environments, meeting safety and efficiency goals. This prototype highlights the potential of automated systems to improve vaccine transportation, reducing risk, and enhancing hospital operations.
My final slide here, I got future works. So here we have enhancing obstacle detection and path planning, refining user interface for hospital staff, and conducting real world tests in clinical settings. So, sure, our product is completed. While we have made significant progress, there's more to be done. So, next semester, we want to focus on improving obstacle detection and refining the path finding or path planning algorithms. We'll also enhance the user interface and make it more intuitive for hospital staff. And finally, we aim to conduct real world testing to validate the system's functionality in clinical settings. So as of right now, our group member Austin has the main unit. Since we are all distant students, we've been working hard at coding and adding physical changes to it, reviewing, having meetings, discussions, talking over it, video conversations. There is quite a bit more we want to do and we want to add on in Capstone 2. But as of right now, the RC car does function like an RC car should. You can send it instructions. You can tell it what to do. It does detect. It does have sensors. It does have a camera built onto it as well for viewing, and all of that has worked great for the most part. But this future work here, we want to just take it to the next step. We want to polish it even further, make sure it fits all the goals we need so that it can function in a clinical setting within a hospital. And once we feel like we have a solid product within Capstone 2, we'll do some real world testing where we can mimic a hospital event inside a house and tell it, this is room 110, go here, drop this off, and then see how it works from there before we completely have a complete product that we are fully on board with. And thank you.
So, in conclusion, the RC Pi car represents a step forward in healthcare logistics. By making vaccine transportation very autonomous, we can minimize risk, improve efficiency, and ensure patient safety. We're proud of the work that we've done so far and excited about the potential impact of this system. Thank you for joining us, and we look forward to answering any questions that you may have now and also working on this more in Capstone 2.